Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE Chemistry class 10th, chapter number 4, Analytical Chemistry, and so far we have covered the two parts, the two concepts of this chapter, action of NaOH and action of NH4OH on certain metallic salt solutions. Now we are moving ahead to see the last part of this chapter, which is the action of alkalis, NaOH and KOH on certain metals, their oxides and their hydroxides. Okay, so after that we are going to solve some quick questions so that we are done with this chapter. So without wasting much time, let's start and let's rock. Okay, now we are going to see the first part, which is action of alkalis, okay, NaOH and KOH on certain metals. Now, which metals we are talking about here in this chapter? About zinc, about aluminium and about lead. Okay, so what is their action? Very simple. Okay, these alkalis, when they are reacting with these metals, they form salts and they release hydrogen gas. Okay, very simple action. Now we have to just write the reactions of them. Now I always tell you, just remember the general reaction, okay, what is happening, and then you can write the reaction on your own, and then last part is balancing the reaction. Okay, so let's start. So I would start first with zinc. Zinc's action on NaOH, what it would form? Salt and hydrogen gas. So hydrogen gas is released, and which salt is it is going to form? Na2ZnO2. Okay, this Na2ZnO2, sodium zincate. Okay, now what we have to do is just balance the reaction. See, 2 Na, I am taking here 2 Na, 1 zinc, 2 oxygens. So see, 2 oxygen here, 2 hydrogen, 2 hydrogen. It's balanced. Same way you have to write the reaction for KOH. Okay, so zinc plus KOH, what it would give? Salt and hydrogen gas. So first I'm writing the hydrogen gas is getting liberated, and salt would be same like sodium. It was forming sodium zincate. Now in case of potassium hydroxide, it would form potassium zincate. Formula would be exactly the same. Na2ZnO2, then K2ZnO2. And what is this name? Potassium zincate. Okay, now balance it again. Now once you have balanced the sodium reaction, means the reaction of sodium hydroxide, okay, just put the same numbers for the potassium hydroxide, because when you would balance it, actually you would find that yes, the whatever we have taken the numbers, okay, for balancing the reaction for sodium hydroxide, the same numbers are required for the balancing the reactions of potassium hydroxide. Okay, exactly the same. So here 1 2 1 1, that's it. Okay, so this is a simple trick. If you are asked to write the reactions, okay, for both of them, for the action of sodium hydroxide as well as potassium hydroxide on certain metal ion, once you write one reaction for sodium hydroxide, then for potassium hydroxide you have to repeat the same reaction. Okay, just slight changes would be there, and the balancing part would also be the same like that of the sodium hydroxide case. Okay, so I have told you a trick. Now moving to the case of aluminium here. So aluminium, now it's like slightly different. Aluminium react with the boiling caustic alkali solutions. Okay, so what does this mean? Caustic alkalis means this potassium hydroxide and sodium hydroxide. Okay, now they're boiling solutions, it's the same. So what we would take is, we would take sodium hydroxide, and we now are talking about the solutions. So water would also be there, and here we have to take water as well, and then potassium hydroxide and water as well. Now the products would be the same. What would be the products? Salt and hydrogen gas is liberated. So here first I would write the hydrogen gas is getting liberated. Okay, now which salt would be formed here? In case of aluminium and sodium hydroxide, they combine along with water to form sodium meta-aluminate. Okay, sodium meta-aluminate. Now, what is its formula? See, simple, NaAlO2. Okay, one sodium, one aluminium, two oxygens. Same way, aluminum would react with potassium hydroxide and means aluminum would react with the boiling potassium hydroxide solution. Okay, and it would form same potassium meta-aluminate. Okay, so the formula would be exactly same like that of the sodium, KAlO2. Okay, now the last part is to balance the reaction. So you try on your own to balance the reaction. I'm directly writing the numbers, okay, because we won't waste time in balancing the reaction. It's very basic now. You know how to balance the reactions. So you pause here, you try to balance the reaction, then unpause again. So you would see the right answers. Okay, so 2Al, 2NaOH, 2H2O, and then 2NaAl2 and 3H2. Same goes with this 2Al, 2KOH, 2H2O. 2KAlO2 and 3H2. Okay, so this is the balanced one. Now the last metal, lead. Okay, so reaction of lead with first sodium hydroxide, reaction of lead with potassium hydroxide. Okay, what it would give? Simply salt and hydrogen gas. So, and which salt it would form? Hydrogen gas is liberated. Okay, just like zinc. Zinc was forming sodium zincate. Here it would form sodium plumbite. Okay, now we know these salts actually. We have studied about them in the previous part. Okay, and here it would form potassium plumbite. Okay, now formula, we also know the formula as well. Na2PbO2, same like zinc, sodium zincate, and K2PbO2. Now let's balance this. So you pause here the video, you try to balance it on your own, then again unpause it. Okay, so yes, that's balance. Na2PbO2, Na2PbO2, and then H2. Okay, same K2PbO2 and H2. Okay, okay, now let's move on to the next topic, amphoteric nature of metal oxides and metal hydroxides. Okay, so first let's start with this metal oxides. Now what are these metal oxides? These are just the compounds having metal atom and oxygen atom, right? For example, Na2, sodium oxide, metal oxide, right? And these metal oxides, when they are treated with water, they form metal hydroxides. Okay, so for example, let's take this one. Okay, sodium oxide itself, I'm treating it with water and it is forming sodium hydroxide. Okay, NaOH. See, 2Na, 2Na, 2O2H, 2O2H, it's balanced. So what we have observed is generally what is happening, these metal oxides and these metal hydroxides, okay, they react with acids and form salt and water. Okay, so can you just try to correlate it with the previous chapter which we have studied? See, we know that who reacts with acids to form salt and water? Bases, right? So bases reacts with acid to form salt and water. Now these metal oxides and metal hydroxides are also reacting with acids to form salt and water. This means that they are having like base-like nature, right? So we call this base-like nature as basic nature. Okay, and that's why we say that generally metal oxides and hydroxides are having basic nature. Okay, throughout it's clear. Now let's take an example to understand this thing. See, I'm taking the same metal oxide, same metal hydroxide. Okay, they are reacting with this acid HCl and they are forming the salt NaCl, okay, and water. Okay, throughout. So now I hope you can balance the reaction on your own because it's like quite simple. Okay, you can pause it here, then again resume back to see whether you have balanced it right or wrong. So two sodium atoms right here. Then one oxygen atom, okay. So see here, one oxygen atom, and then two chlorine, two hydrogen. So two chlorine, two hydrogen, okay. Same here, NaCl H2O, NaCl H2. So it's balanced. So this was the basic nature which we studied right now of metal oxides and metal hydroxides. Now there comes an interesting thing, okay. There are some of these metal oxides and metal hydroxides, they behave differently, okay. How they behave differently, let's see. So what some of them do, some metal oxides and metal hydroxides, they react with acid and form salt and water, but they also react with bases and form salt and water, okay. So this means that, see, we have studied just now that since these are reacting with acids to form salt and water, this means that they are having base-like nature. So we are calling them as having basic nature, these metal oxides and metal hydroxides. Now, the same metal oxides and metal hydroxides are also reacting with bases to form salt and water. This means that they are behaving like acids, right? Since acid reacts with bases to form salt and water, so they are also behaving like acid only. And since they are behaving like acid, we are saying that they are having acidic nature, okay, the same ones. Now, these metal oxides and metal hydroxides are having both acidic as well as basic nature, okay, and such metal oxides and hydroxides which are having both acidic and basic nature, we call them as they are having amphoteric nature, okay. So we call these metal oxides and metal hydroxides as amphoteric metal oxides and amphoteric metal hydroxides. Now let's see an example for them. Which of these metal oxides and metal hydroxides behave like this? So see, here are the examples. Zinc oxide and zinc hydroxide, okay, behave like this. They are having amphoteric nature. Secondly, aluminium oxide, okay, and aluminium hydroxide, they are also having amphoteric nature. And lead oxide and lead hydroxide, okay, they are also having amphoteric nature, okay. So these three cases we are going to see in this chapter, okay, that's why I have mentioned them. So let's start with this first case. First of all, I am just taking an example for this first case, okay. So zinc oxide and zinc hydroxide. So what I would do is I would treat both of them first with acids, suppose HCl, and what they are giving me, okay, since now these are amphoteric in nature, so they would react with acids to form salt and water. So yes, they are forming salt, see, zinc chloride and water, okay, and same way zinc chloride and water, okay, the salt is formed, which is formed is same, okay. Now I would react this zinc oxide, see, now this zinc oxide with a base NaOH, okay, and what they are giving me, see, again a salt and water, sodium zincate, Na2ZnO2 and water, okay, and same hydroxide, zinc hydroxide with base, and it is also giving me salt and water, the same salt and water, okay. So salts which are given, okay, in the case of oxide and hydroxide when they are reacting with acids is same, and same way the salts which are given in case of oxides and hydroxides when they are reacting with bases, they are also same, okay. So again Na2ZnO2 and water, okay, Na2ZnO2 and water. So see here, you can clearly figure out zinc oxide and zinc hydroxide reacting with acids and bases to form salt and water. So they are having, see, basic nature. And this zinc oxide and zinc hydroxide reacting with bases to form salt and water, they are having acidic nature, correct. So that's why we are calling these zinc oxides and zinc hydroxides as they are having amphoteric nature, okay. Now all these reactions, I have just written down the reactions which are of the particular oxides and metal oxides, so you can try balancing on your own. Now we have balanced a lot of reactions, so you can just try on your own to balance this reaction. These are very simple reactions, okay. And yes, the one last thing about this concept is the definition of amphoteric oxides simply, okay. So what are amphoteric oxides and hydroxides, okay, and amphoteric hydroxides. So they are simply the oxides and hydroxides, okay, which react with both acids and bases to form salt and water, okay. So I have just condensed this definition, okay, in simple terms for you to remember. Those oxides and hydroxides which reacts with both acids and bases to form salt and water, such oxides and hydroxides are called as amphoteric oxides and amphoteric hydroxides. So moving ahead to the last topic of this chapter, okay, action of alkalis. Now which alkalis we are here talking about? NaOH and KOH. Okay, on certain metal oxides and metal hydroxides. Which metal oxides and which metal hydroxides are here we talking about? We are talking about this metal oxide: zinc oxide, aluminium oxide, and lead oxide. Okay, and which metal hydroxides here we are talking about? Zinc hydroxide, aluminium hydroxide, and lead hydroxide. Okay, so how would be the action of NaOH and KOH on these oxides and these hydroxides? So now can you remember, just now we have studied these oxides and hydroxides, they are having amphoteric nature, right? We have just seen the example of the oxides and hydroxides which are having amphoteric nature, and these three were there in that example. So this means that what are amphoteric oxides and hydroxides? Simply these are the oxides and hydroxides which react with acids as well as bases to form salt and water, right? So here see, these are the bases. So how would they react? They would react with these bases to form salt and water, right? They also react with acids to form salt and water, but now here there are bases, so we are concerned with the bases. So these would react with bases to form salt and water. That's it. So same way, now we are going to see these metal oxides. Okay, I am just denoting all these metal oxides as MO and all these metal hydroxides as MOH. So these metal oxides and metal hydroxides would react with these bases, okay, to form salt and water. Very simple. Now what we have to do is, one by one we have to make them react. Chalo, come and react. So first I would take the reaction. Okay, first I would see the action of NaOH on zinc oxide and zinc hydroxide. Okay, one by one we would go, very simply, very easily. Okay, so zinc oxide and zinc hydroxide, chalo, come here. Okay, now let's see their action with NaOH. Okay, now I'm going to tell you a very simple trick, okay, to remember these reactions. They are like very similar, but after seeing this so many reactions, we feel that, oh, there are so many reactions, okay, but they are very similar. See, if you are having this zinc oxide and zinc hydroxide in these reactions, whatever oxide and hydroxide you are having, if you are treating it with same reagent, okay, same reagent. Now here we are having the reagent NaOH, okay, it would give you same salt, okay, both of them would give you the salt which is same, exactly the same, and water. Okay, now here in this case, which salt is getting formed? Na2ZnO2. Okay, same salt in both the cases, Na2ZnO2. See, we are done with the reaction simply, and then you need to balance the reaction. Now you would balance it, because we won't waste time in balancing this reaction. There are so many reactions, right? So you can pause here, you can balance it, and then we would move ahead. Okay, so now this was the action of NaOH on zinc oxide and zinc hydroxide. Same way we are going to see the action of KOH. Okay, how KOH would be acting on them? So see, zinc oxide, zinc hydroxide, okay, KOH, KOH. Now same trick we will apply. What I have said you, see, if you are the given zinc oxide and zinc hydroxide, okay, the metallic oxide and metallic hydroxide we are taking, and if we are and when we are treating it with same reagent, okay, that particular metallic oxide and metallic hydroxide should be of same metal. Okay, we are talking here about zinc oxide and zinc hydroxide, Aluminium oxide and aluminum hydroxide, lead oxide and lead hydroxide. Okay, not beyond this. Don't take the trick beyond this. Okay, this is the trick for only these cases. Okay, now when we are talking about zinc oxide and zinc hydroxide, okay, and we are treating it with same reagent, okay, they would give us the same salt, okay, and water. Now which salt would be there in case of potassium? Potassium zincate, okay, K2ZnO2, and here also K2ZnO2, okay, exactly the same. Now what is remaining is just to balance the reaction. Okay, now moving ahead, let's take the next oxides and hydroxides, aluminium oxide and aluminium hydroxide. Okay, now let's first treat it with NaOH, both of them. Now the same trick you have to apply. Okay, these oxides and hydroxide, okay, of same metal, here aluminium is there. Okay, when they are reacting with same reagent, they would give us same salt, okay, and water. Now here what salt would be formed? Very simple, sodium meta-aluminate, NaAlO2 is the salt which is getting formed. What its name? Sodium meta-aluminate. Okay, very simple. Now same, its reaction with KOH. Now I am taking the aluminium oxide and aluminium hydroxide and I am treating it with KOH. Same trick we are going to apply. This oxide and this hydroxide of aluminium, okay, if we are treating it with same reagent, they are giving us same salt and water. So which salt here they are giving us? Same, sodium meta-aluminate, sorry, not sodium meta-aluminate, here it is potassium. See, so potassium meta-aluminate and potassium meta-aluminate, okay, KaLO2, KaLO2, okay, the same salt and water. Now rest is to balance it. Okay, now last oxide and hydroxide, lead oxide and lead hydroxides reaction with NaOH. So see, oxide and hydroxide with same reagent, okay, what they would give us? Same salt and water, simply. So what salt it would form? Sodium plumbite, Na2PbO2, okay, just like Na2ZnO2, it is forming Na2PbO2, Na2PbO2, okay, sodium plumbite. Very simple in both the cases. And now lead oxide and lead hydroxide with KOH. Okay, so again see, oxides and hydroxide with same reagent would give us same salt and water. So see, K2PbO2, potassium plumbite, okay, like sodium zincate, here it is sodium plumbite and potassium plumbite, okay. So I would just write the names in order to avoid the confusion. Sodium, it's plumbite, okay, not plumbate like zincate, okay, plumbite. Here it is potassium plumbite, okay. The formula is of same type but the name is slightly different, and here also the same salt, K2PbO2, okay. Now rest you have to do is just balance the reactions. So now let's see some questions. Okay, so not much questions are being asked from this part of the chapter. Okay, just one question I found in 2018 examinations, so which is reaction of zinc with potassium hydroxide solution, and what you have to do is write the balanced chemical equation for this reaction. Okay, so very simple, zinc with potassium hydroxide solution. Now we know their action of alkalis NaOH and KOH on these metals, zinc, aluminium and lead. What is their action? They form a metallic salt and they release hydrogen gas, right? We have studied the first action of alkalis on metals, right? They form metallic salts and hydrogen gas is released. Now which salt it would form? Simple, K2ZnO2, potassium zincate and hydrogen gas. Now balance it. So K2, K2, zinc 1, zinc 1, O2, hydrogen 2. So O2, hydrogen 2, balanced. Okay, very simple. Now these two I have made on my own. Okay, the same type of questions I have tried to make so that you would get some practice. Reaction of lead oxide with NaOH. Okay, now how would they react? See, oxides and hydroxides. Okay, this lead oxide, first of all, it is, yes, amphoteric oxide, right? We have studied. And this amphoteric oxide, we know they react with both acids and bases to form salt and water. So here it is a base, so it would react with this base and it would form salt and water. Okay, now which salt it would form? See, Na2PbO2, sodium plumbite, Na2PbO2. Okay, just now we have studied. Now balance this reaction simply. So see, 2Na, 2Na. Okay, Pb is 1 Pb, O2 and here O1. So O are 3 that side. So see here O are also C, 2 and 1, 3, balanced. And then H2, remaining is H2. So see here 2H. Okay, so reaction is balanced. Simple. Now next is reaction of aluminium hydroxide with KOH. Okay, so I will write here itself, aluminium hydroxide, AlOH thrice, with KOH. Okay, now again see, metal oxide, metal hydroxide. So here this is a metal hydroxide and its reaction with NaOH or KOH. So here it is KOH. Okay, now we know that, see, this is aluminum hydroxide which is amphoteric in nature. So it would react with both acids and bases to form salt and water. So here it is a base, right? So it would react with this base to form salt and water. So simply, so which salt it would form? It would form, in case of potassium hydroxide and sodium hydroxide, when they are reacting with this aluminium hydroxides and aluminium oxides. Okay, which salts are formed? Metaluminate salts are formed. Okay, in case of KOH, it would form potassium metaluminate. See, KAlO2. This salt it would form. Okay, now what is remaining is just we have to simply balance the reaction. So see, starting from K, 1 K. Okay, aluminium 1, fine. Oxygen 2 and 1, 3. So here see, oxygen 1 and 3, 4. Now here there is here the oxygens are not balanced. Okay, so let's try to balance them. See, 3 oxygen and 1, 4 oxygen here there are. So I would make here also 4 somehow. So how I would make 2 oxygen and 2 oxygen, 4 oxygens. Okay, now oxygen is balanced. But what has happened? See, now moving to hydrogen, 4 hydrogens are there now here. Okay, so for making 4 hydrogens, see here there are how many hydrogens? See, 3 hydrogen and 1 hydrogen. So there are 4 hydrogens. So yes, that's it. We have balanced it. Okay. So AlOH thrice plus KOH, KAlO2 plus 2H2O. So friends, with this we have reached the end of this video and we have completed this chapter. We have studied all the concepts of this chapter in these 3 videos. Okay, so I hope you would have enjoyed learning with me. You would have understood all the concepts of this chapter, but please do let me know this thing in the comment section. And as you all know, LearnoHub matlab free hai par best hai. So then stay tuned. We will meet in the next video with the next chapter. Till then, bye bye and have a great day.